Hi all, welcome to my channel. In this video, we can see important portions or important points of simple stress and strain chapter in strength of materials. Like this, we can see every chapter, important topic wise as well as important chapter wise. You can only study, at least study these points, and you can do all the problems from this books. Okay, let's start it. First is simple stress and strain. So before designing structures, we need three parameters. One is strength, and one is stiffness, and one is stability. So these three is essential for constructing a structure, or these three are the design parameters of a structures. So this is the reasons you need SOM structure or SOM subject to study. Next is there are like homogeneous, isotropic, and isotopic. So mainly in exams there will be questions related to homogeneous and isotopic. Homogeneous means same composition. Same compositions means like the properties here, the properties will be same. Here the properties will be same. Here property will be same. So some properties are identical in this directions, and it will be homogeneous. Okay, that means same composition. So that is homogeneous. And talking about this isotopic, isotopic means what? Isotopic at a point in perpendicular directions, properties are different. So you can remember like this also, or you can say like this is perpendicular directions, right? So in this perpendicular directions the properties are different, or the properties same in all direction at a point, different at other locations. So this is same meaning of at a point in perpendicular direction properties are also different. Next another questions you can get from this point is are all homogeneous is isotopic and all isotopic are homogeneous? So this is also a questions you can expect from this. Answer is no, all homogeneous need not be isotopic and all isotopic need not be homogeneous. And next is stress. Okay, so stress means what? It is a resisting force per unit area. That is stress equal to P by A. Stress equal to P by A. Okay, so stress equal to P by A. So P by A, P is nothing but this resisting force per unit area. That resisting force is called that P, and it is not load. You should say that you should say it is resisting force. Next, or you can say this applied force per unit area also. And what is this unit of stress? It is also very important questions which is asked in all kind of examination. The unit of stress is not vector, or what is it? Is tensor. It is not vector. It is not a scalar quantity. It is a tensor quantity where it have magnitude and many direction. Okay. So this is a very important question. And next is if this resistance in equations you can expect like this. For example, 1 minute. Okay. For example, they will say in equations like if this r equal to 0, then what will be the stress? Stress will be 0 only, right? So if this r equal to 0, then in this member it will be free to expand and free to contract. If there is no resistance, or that member will be free to expand and free to contract. And the stress unit is nothing but it is what is the quantity of stress? If they ask, just write tensor. So they will give scalar, vector, and tensor. So you should have that idea on what is this quantity of the stress. And what is this unit of the stress? Unit of the stress is nothing but this. It is Newton per meter square, or you can say it as Pascal. Okay, that is regarding stress portion. And you should study what is superposition and superposition limitation, validity of superpositions, why it is not valid, and in which structure it is not valid. So this is a very important topic you should remember in all kind of examinations. So superposition topic is also, it is very less. At least you should know what are the limitations of superposition. Like this load will be stress strain will be at proportionality limit only. So Hooke's law will be valid till proportionality limit only. And the second limitation is the deformations are very small, and these two are the limitations. And talking about this validity, it's not valid for the T beams, non-circular members subjected to torsion. So these 2 points, you should remember these 2 points. Next, okay, talking about this unit of stress, this Newton per meter square is also called this Pascal, or you can say N per meter square. It is called as this is megapascal. So Newton per meter square is Pascal. So m Pascal. So mega means what? 10 raised to 6. Okay. Next is 1 Newton per mm square. So 1 Newton per mm square means it is, just think and write. You can write in this comment section. Or okay, like I'm just saying 1 Newton per mm square is also called as what is megapascal. Okay, Newton per mm square. And next is giga. 1 Newton per meter square equal to 1 gigapascal. So Newton per meter square is pascals, and next is giga. Giga means 10 raised to 9. So this unit conversion will be useful while you are solving problems. Okay. Next, 10 raised to 3 Newton per mm square equal to 1 gigapascal, or you can write this as 10 raised to 3 megapascal. And I have already mentioned that what is the stress? Stress is nothing but it is this resisting force per area, that is P by A. So this is for this normal load. What if in questions they have given sudden load? If they have asked you sudden load, then you should write 2 P by A. Instead of taking P by A, you should take 2 P by A. So don't forget to take 2 P by A also. And next, and okay, so if they'll okay, one question. So I'll ask you one question. Okay. Okay, so I'll just say the question. If they'll give you a member and they'll give like that member is free to expand and contract. So that member is free to expand and contract. They will ask you what is the stress value. Okay, as the resistance is zero in that, as the resistance is zero in a member where it is free to expand and contract, then the stress is also will be zero. That you should remember. Okay, so that's all about the stress. And next is talking about the strain. Strain is nothing but change in dimension by this original dimension. If it is of this length, then change in length divided by original length. And if it is of this volume, so volumetric strain means what? Change in volume divided by this original volume. And it is of the shear means what? Shear volume. Sorry, shear strain. Shear strain means it is due to the shear force. And this is also a question which is asked in many competitive examination. So normal strain and volumetric strain is caused due to normal force. Then what about the shear strain? Shear strain is caused due to shear force. Okay. Next, it is this. What is this unit of strain? There is no unit. It is it is just a ratio, right? So there is no units. Next, one question you should remember is what is independent? Which is independent parameter on the stress and strain? Is stress a independent parameter or strain? So answer is strain is an independent parameter. Next, okay, so next is this is okay strain. This is about this normal strain. If it is for this, okay, so that's all. Change the dimension by original dimension. Just remember that for strain. So change the length divided by original length. If it's for this volume, change in volume divided by this original volume. And for the shear strains, you should remember it is due to this shear force. Okay, and next year, okay, you should remember what is the stress strain diagram for this mild steel in this tension and as well as for this compression. So I'll just draw this graph. Okay, before that we can see what is this. Okay, if this is if it is an angle, the strain will be like it will deform like this. Okay. Okay, so what will be the diagonal strain? It will be gamma by 2. It's not important, but they just know it. Then okay, so according to Hooke's law, or Hooke's law is nothing but the stress is directly proportional to strain up to what? Up to this is proportionality limit. So for that we will introduce a constant sigma equal to EE. So E is nothing but this Young's modulus. So Young's modulus of the steel is also very important. Just remember that Young's modulus of steel is 200 gigapascal. So don't forget that also. So I will draw the stress strain curve. And okay, so this if this Young's modulus is more, then it is more elastic. If Young's modulus is less, it is less elastic. So remember that also. And if it is more, it has this more resistance to volume. Okay, next I will just draw the stress strain graph. This is stress strain graph of this mild steel. This is very important. So according to this stress strain graph, you can have many questions. So don't forget to learn all these graphs or from of this mild steel in tension as well as in compression, and don't forget to study this different what happened when in this graph if this carbon content is increased. So there are many questions regarding that. So don't forget that. Don't forget to study all these things. Okay. So in this just have that points. Okay, wait. Okay, you should remember the points. So if this is so O is this proportionality limit and B is this elastic limit. So this is upper yield point, this is lower yield point, and okay. First I will mark all the points. So this is E and this is F. G is okay. So G is breaking point and F is this is ultimate point. And this graph. Okay, so OA is nothing but it is this proportionality limit according also, or it is the portion where Hooke's law is valid. So OA is the portion where Hooke's law is valid, and AB it will be no linear. So this is not at all a straight line. So it will be no linear elastic zone, and you can say this B is this elastic limit, and CD is nothing but it is a yield zone, and DE is plastic zone, and EF is strain hardening, and FG is strain softening region, or you can say necking region also. And here it will be 200, that yield stress will be 200, and this is stress strain curve. I forgot to, okay, so this is stress strain graph of this mild steel in tension. Okay, that's all. And okay, that's all for this portion. We have okay. Next is this Poisson's ratio. So what is this Poisson's ratio? Poisson's ratio is nothing but this. It is a ratio of this lateral and this longitudinal strain. So that is this Poisson's ratio. And don't forget to learn this value of this Poisson's ratio. What will be the value if it is 0? What will be the value if it is 0.5? And so just remember all those things. And for this Poisson's ratio, there is no unit. And the range of this Poisson's ratio, it will be like 0 to 0.5. So 0 for this cork and 0.5 for this incompressible material. So this is also very important questions asked in all kind of examinations, so don't forget that value also. And mu equal to that 0.25 for this isotropic material. So mu equal to 0 for this cork and the 0.4 for this incompressible material and the 0.25 for what? 0.25 for isotopic material. And this mu is approximately 0.5 for this rubber, clay, mercury and paraffin wax. And okay, for 0.5 I told it is for this incompressible material, right? So what is this incompressible material? Can you please tell one example of this incompressible material? So ideal fluid is an example of this incompressible material. So what is this ideal fluid and properties of ideal fluid? This is a famous question asked in all kind of examination. Okay, so we have learned the 0.5 and 0.25 for all this kind of this materials and 0.5 for this incompressible material. So this example for this incompressible material is this ideal fluid. So for this ideal fluid, densities should be constant, surface tension should be 0 and this viscosity should be 0. So this is very important questions will be asked. So for this incompressible material, the three should be remembered, like for example for this ideal fluid, the density should be constant, surface tension should be 0 and viscosity should be 0. That's all. And next is for this volumetric strain. Okay, strain. Before getting to that, we can study. Okay, so what is this hydrostatic stress? Hydrostatic stress means what? Concentration of this elongation size only, like sigma x equal to sigma y equal to sigma z. So at three sides the stress will be equal. And for this generalized Hooke's law, there are relationship between okay, so for this is for this generalized Hooke's law. So that is Ex equal to 1 by E into sigma x minus mu into sigma y plus z. And this is the same case if for this ay it is 1 by into sigma, instead of x it will be like sigma y minus mu into sigma x plus sigma z. So this is all about this Ex, Ey, Ez. So learn that also. And next is this Ev equal to Ex plus Ey plus Ez equal to, if it is for the set, next is the sigma x plus sigma y plus sigma z divided by the C into 1 minus 2 mu. And next is for this dilation, Ey equal to change in volume divided by the original volume. So volume of this volume for this rectangle LBH, and if it is for the cylinder, pi by 4 d square L, and if it is for the sphere, it is 4 by 3 pi r cube. Okay, next elastic constant. So this elastic constants questions is very important. And first is like you should study what is, instead of studying this elastic constant, this relation is also very important. So first this is also very important. So these two are also very important. So equal to 2g into 1 plus mu equal to 3k into 1 minus 2 mu. So when this Poisson's ratio increases, it will be more ductile, and mu equal to 0.5 for this rubber, and 12th point is not needed for you. Okay. Next, this also not needed. Okay, and for this brittle, ductile and malleable, for this brittle it will be compressive or tensile. That is, this the meaning of this plus and minus is it can be compressible or tensile. And for this ductile it is compressible, and for this malleable it is tensile. Okay, next is low plastic zone. For this brittle it is no plastic zone, there won't be any plastic zone. For this ductile it will be having large plastic zone, and for this malleable it is having this large plastic zone. And you should study the difference between, so what is creep? So creep means, you should study some. Okay, I'll just include here. Okay, as well as you should study what is this creep. So creep is nothing but it is a deformation at this constant load or stress with this prolonged time. So when the stress is given to this prolonged time, then this deformation caused in a material is called as creep. So this is also very important question in all examinations. In match the following questions you can find this creep. And next is about this endurance limit. Endurance limit. So endurance limit is nothing but it is a stress level at or below which the material will not fail due to repeated loading. Okay, so that is endurance limit means below or at that point. Even if we give this repeated loading, the material won't fail. That's all. Next, you should study this toughness. Toughness is nothing but it is an ability or ability to absorb mechanical energy up to this failure or this fracture, and it will be under this impact loading. And resilience means this ability of this material to absorb the strain energy till elastic limit. Okay, so that is for this resilience. So till elastic limit, it is for this resilience. So you should remember resilience. And next, fatigue failure. Okay. Next, you should remember this normal strain. Normal strain. Normal strain is the change in length divided by original length, or the A naught divided by A equal to 1 plus E, and sigma naught equal to sigma into 1 plus or minus strain, and E naught equal to ln of this 1 plus or minus E. So you should remember this formula also. And another formula you should remember is Et equal to 2 ln d divided by this d dash. So this formula is very important for many objective kind of examination. And modulus of resilience, and this what is modulus of resilience means? So area below the stress strain curve up to proportionality limit. So that is this modulus of resilience. Complementary modulus of resilience means area above the stress strain curve up to this proportionality limit. So go through the different what is this fatigue failure, resilience, modulus of resilience, toughness, and Westinghouse effects. Westinghouse effects means reduction of this yield due to the cyclic loading. So remember that also. And hardness. Hardness means ability to this resist the scratch or this abrasion. Don't forget to learn that also. Okay. And okay, so it's all, I think I have covered many. Okay. Okay, so next okay, so in the stress strain graph, they will give you like here they will give you diamond, and here the graph is for this high carbon steel and this medium carbon steels and this mild steels, and rubber will be here like this. So when this X component increases, then it is more ductile. When Y component increases, it will be more strong. When X and Y component both increases, it will be more toughness. It will be having more toughness. So this is what I have seen. When this carbon content increases, X component decreases, but this Y component decreases. So here it is high carbon steel. So this graph is very important. So here high carbon steel, medium carbon steels, and low carbon steels. So I already told you what is grave. So it is deformed with a sustained load or this prolonged load for a long time. And factor of safety is nothing but is failure stress divided by this working stress. And that's all. Next we can learn about this elongation. So what is this elongation? For this different elongations, there are different formulas. So elongation, the basic formula for this elongation is the change in length equal to PL divided by this AE. So the questions based on this won't be asked in any examinations, but elongation of tapered bar and elongation of this elongation due to self weight. So you can expect questions from this part only. And next is AE means what? AE means axial rigidity. That also important. Okay, if it is for the tapered bar, so the questions can be asked like this. If it's for the tapered bar, then this deflection of this AB plus deflection of this BC, so these two deflections you just add is nothing but this PL divided by this AE of this 1 plus PL divided by this AE of this 2. Okay. Next, if it is due to the self weight, then this deflection equal to gamma L square divided by 2E, or it can be written as this WL divided by this 2AE. So remember this formula. So at least remember this formula, WL divided by this 2AE. And here it is for this gamma L square divided by 6E. Here it is 2E for this rectangle, and here for this triangle it is 6A. And next is bar of this uniform strength A equal to A naught into E raised to gamma x divided by E sigma. So you can get exactly, you can get a question from this formula. So we'll be getting. Okay. Okay. So we have already just gone through everything, most important formulas in all. And you should remember this independent elastic constants for this homogeneous plus this is isotropic, and for this homogeneous and this orthotropic, and homogeneous and this anisotropic. For homogeneous and this isotropic, it is this is two elastic constant, that is one is E and one is mu. And for this homogeneous plus isotropic, it is 9, and for this homogeneous plus anisotropic, it is 21. Total elastic constant will be 4, and for this volumetric strain, you should remember this also. For the cylinder, it is EV equal to 2 into this is EH plus EL. So EH is nothing but it is hoop or this circumference stress. And next is EV for the sphere, it is E 3EH. And okay, for this volumetric strains, delta V by V equal to, I have already just given this, into 1 minus 2. Okay. Okay, next you can expect for this known uniform bars, you can expect this questions. At a distance here, if it is Dx at a distance x, L. So this is deflection equal to 0 to L P dx divided by this AXE. And A is, so A means what? Axial rigidity. So unit of this A is nothing but this N. And axial stiffness equal to AE divided by this L. So this is axial stiffness. And next, okay, I think we have covered everything. Okay, next, bulk modulus we have covered, I think. Bulk modulus unit is Newton per mm square. And next is about this thermal stress. So thermal stress, alpha equal to, you should remember this value, 12 into 10 raised to minus 6 per degree Celsius. And next is this expansion. So what if having this free expansions, what if you are giving some load, and stress develop will be 0 if this memory is free to expand. And so sigma equal to E alpha delta T. And if this temperature increases, then this compressive will be positive, and if this temperature decreases, then tensile will be negative. Okay, that's all. Okay, and you can expect these questions from nut and bolt problem. Bolt problem. Here, extension of this bolt in that questions, in that type of problems, you should give like extension of bolt, compression of steel equal to movement of this nut. So nut and bolt problem is very important. Okay, and different graphs are all important. So what if the graph for this perfectly rigid? So perfectly rigid means this is graph for perfectly rigid, and nearly rigid means this is stress strain graph. Okay, this is nearly rigid, and this rigid strain hardening, this is for this linear elastic plastic, and this is linear elastic graph, and this is linear elastic strain hardening, this is rigid strain hardening, and this is for the ideal fold. So remember the graphs like this, so that will also be important. And when this in this graph, when this carbon content increases, x component will just decreases, x components will be decreased, ductility will be decreased, toughness will be decreased, and y component increase, and strength increase, and brittle also increase. Just study the importance of this, what is ductility, what is brittleness, what is toughness, just study all this. And for this brittle material, you will be like drawing, this is for this compression, and this is for the tensions, and there you will use proof stress or 0.2% yield stress. And tenacity is nothing but it is a property of material to resist fracture under the action of the tensile load, especially used for the strength of flexible fibers. And ductility means drawn permanently over great change of shape without rupture. Brittleness, failure without this warning. So that is brittleness. And toughness, it is absorption of this energy at high stress without rupture. So I think okay, that's all for stress and strain part. In next video, we can see about shear force and bending moment, important concepts and important quick revision on that. Okay, thank you for watching and keep learning. Thank you.